Yeah, in case you missed it, I'm Sam G from Zayndu. I'm a plant scientist, and today I'm going to tackle the topic of the importance and the benefits of reducing germination time. And before I start, it might seem like a bit of a probably common topic. I mean, I'm sure we're all aware on what germination is, but the angle that I want to take, and I suppose I'll kick off. The angle that I want to take is that I think in a lot of cases it can sometimes be overlooked. I think sometimes seeds can be mishandled and mistreated, such that people and growers aren't getting the most out of their seeds as perhaps they could. Germination, of course, is the first step in any growing cycle, in any growing facility. And so I think it's important that care and attention is provided for seeds. Because I mean, the effectiveness of your germination output ultimately is going to determine the value of your crop cycle and your yield. I think in a lot of cases, perhaps, growing facilities are optimized for maximizing yield, giving plants the best possible life, which is great, but it can only go so far. And I think at the risk of perhaps sounding harsh, if you're not getting the most out of your seeds and your germination, then it doesn't matter. You're not going to get the most out of your growing cycle, for example. So sort of tackling the notion of minimizing losses in seeds and germination in order to maximize gains, which again, sometimes from growers is overcompensated for by overseeding, which is a bit of a waste. I mean, I remember an example 2 years ago. I won't drop anyone in it, but I had the experience of we were working with 4 distinct species, and before these went into growing conditions, they'd cast them aside into a germination room at extremely high temperatures. And providing that one of these species was spinach, it was suboptimal, let's say. So it made me think like people are causing stress to seeds before they've even started growing. And there's 2 examples here on the right-hand side. I'll get my laser pointer because we love a laser pointer. There are 2 examples here on the right-hand side from germination tests that I've done. These are just 2 random ones. I had a fair few to choose from, just to pose the question, I suppose, of how valuable is a 5 to 10% increase in germination if you provide a little bit more care and attention. And so the reason that I'm talking about this is because seeds, being seeds, are held in a quiescent state, right? So germination is not the standard. And the reason for this is because, as you can see on the right-hand side, the internal hormonal network for seeds is very intricate. One of the main players here is ABA, abscisic acid, which acts to repress GA, or gibberellic acid, which is your germination promoter. And in this way, it acts to promote dormancy. Now, most seeds inherently aren't dormant, but they are held in a quiescent state, as I say. And beyond this, you have the embryo surrounded by the seed coat, which is made up of cutin and external waxy layers. You can see this in the bottom right. Now your faces are actually covering it, but here I think I'm pointing to it are some monomeric units of cutin, which are these long hydrocarbon chains. I guess when I say long hydrocarbons, another example would be oil, right? Notorious for being hydrophobic. So from the get-go, you have a seed that is in a quiescent state that's surrounded by a seed coat, which for the most part does not want to absorb water and is hydrophobic. So that's your baseline. But even still, when seeds do begin to germinate, if they're mishandled or mistreated, or they're in a suboptimal environment, it can be very inconsistent and asynchronized. Now, the negative implications this has is that it leads to an inconsistent and unpredictable yield, and it leads to losses in perfectly viable seeds and seedlings, especially for those who are overseeding, for example, and compensating for that. Now, it's common. Again, I think anyone who deals with germination is no stranger to priming. The manipulations to seeds to make them more physiologically ready for germination, so that when it comes to it, they germinate quicker. Now, most priming techniques focus on one of the two things that I've just mentioned. So they may act to alter the internal hormonal balance. So working towards repressing ABA such that GA is no longer repressed and germination can be promoted in this way. So one example of that is stratification. I think that's fairly common. And then the other example is something like scarification. So physically etching the seed to remove the hydrophobic layers, making the seed coat more hydrophilic. I've noted and I wanted to talk about the theory of the oxidative window of germination, right? So I wanted to talk about this for one of two reasons. The first being, I think it encapsulates everything that I've just said so far. So it's the idea that seeds must possess a certain threshold of internal endogenous reactive oxygen species before germination can even occur, right? So it plays into the idea that, you know, seeds are living things. Care and attention has to be administered for your germination to be effective, right? So until relatively recently, I'd say scientists were asking the question of how do seeds know that they're in the optimal environment, right? And I think recently a lot more people are converging on the idea that reactive oxygen species are the culprits, right? So all these different environmental cues that a seed is exposed to, like light, temperature, water, salinity, acidity, all these different things, they contribute to the amount of reactive oxygen species that are present within the seed, right? And on the right-hand side, another figure that I've stolen, I guess, from a paper is the effect that reactive oxygen species are having on all these different important phytohormones. And in this way, they interact, they alter the balance, and ultimately, and hopefully, germination is promoted in this way. Now, the second reason that I bring this up is because it segues quite nicely into what we do. Now, I was permitted a slide on cold plasma, and I'm absolutely taking it. So the thing that we do here at Zayndu is we prime seeds using cold plasma, and we actually tackle both of the obstacles that I've already mentioned, right? So one, based off online scientific literature, is that we alter the internal hormonal balance of seeds, right? So what we do is we take normal atmospheric air, we supply a very small amount of electricity, and in this way, we create a mixture of reactive oxygen and nitrogen species. And what this does is, as I've already mentioned, it alters the hormonal balance. I'm not going to go through it again because I feel like we spoke about it already too much. But the other benefit that we have is that we make these modifications to the seed coat, right? So first and foremost, as you can see in this example here, we create these micropores in the seed coat, so allowing water to enter more freely. The other thing is that we remove carbon from the seed coat and instead enrich it with oxygen and nitrogen species. One of the things this does is that it etches the seed coat such that it makes the surface area to volume ratio larger, exposing more of the seed coat to water, and in that way, water can be taken up quicker. Now, the other thing that happens, which I find really interesting, is when we introduce these oxygen and nitrogen groups, we create these polar groups on the seed surface, right, which have small negative charges and small positive charges. Now, the chemists amongst you, I suppose, will know that water is also polar. And so we create this attraction and affinity to water, and that way making a seed coat more hydrophilic. What this means is the seed can take up water quickly. Of course, with the altered hormonal balance, germination is already promoted. And as you can see on the right-hand side of the screen, there are three examples here. So on the left-hand side in each picture are untreated seeds. And on the right-hand side are seeds that have been treated with this activated air, which in each case leads to quicker germination, more synchronized germination. So in the top, we've got peas, pea shoots. In the middle photo, we've got spinach. And on the bottom here, we've got tomatoes. So three very distinct species, which all exhibit the And the last thing that I want to show you on this slide, it won't let me. I wonder if it is this video of a time lapse that I took, whereby I administer 5 microliters of water to the top of 2 peas. So the one on the left is untreated, one on the right is treated. And you can just see the increase in the water uptake rate. And what I want to sort of get you to focus on initially is when I first put that water down, how it just melts into the treated seed almost. And this is what I was referring to in making the seed coat more hydrophilic. And unfortunately, the camera cuts out because I've done a few of these and my storage blew up basically. So we don't get to see the untreated absorb the water fully. But finally, I just want to wrap up with the benefit to the grower. Excuse me, sorry, that's my voice. The benefit to the grower, just a really generic basic slide, basically pointing out that more germination means more yield. More germination means a reduced need to overseed. In that way, sparing any losses. More germination means more profit. More synchronized germination, again, leads to reduction in losses and seedling waste, especially for those that grow to a certain specification. So the idea is to have more of those plants within that spec, and again, leads to more profitability. And finally, quicker germination, of course, leads to reduced crop cycle time, which means per year you can fit more crop cycles in. And again, the common theme being more profitability. So with that being said, that is the last slide. I'd just like to say thank you for listening. And of course, if you have any questions, I will do my best. I don't know if my boss is hanging around in this chat, but if there's any I can't handle, I will refer you to him. So yeah, I think that was around 10 minutes.